All right, well, welcome everybody. Really appreciate you making it here after lunch. I know it's been a very long week in a very busy place, so thank you all for coming on out. Great to see you all through the lights. Yeah, wave your hand if you're out there. I think there are people out there. All right, is the music supposed to start soon with the bouncing ball? You're like, oh, this isn't karaoke. Shoot.
That's a later session.
I think I'm in the wrong place. Just kidding. Howdy, everybody. Today, we're going to be talking to you about optimizing AWS workflows with the CDK for Terraform. CDK for Terraform is the cloud development kit for Terraform. My name is Taylor Dolezal, and I'm a senior developer advocate at HashiCorp. And I'm joined with my buddy here, Kyle, and I'll intro you to intro yourself.
Excellent. So hello, yes, my name is Kyle Ruddy. I'm on the technical marketing side of the house for all things infrastructure related when it comes to HashiCorp. So that includes getting to do really crazy stuff with Taylor on stuff like Terraform.
Awesome. So let's take a look at what we're taking a look at today. First, we're going to kick things off. I'm going to turn it over to Kyle, who's going to go and talk to us about what has happened with Terraform over the past year. Next up, we're going to talk about Terraform Cloud and, what does that do as well? It stores your state, it runs your Terraform, but what are some other features and some niceties about that? After that, we're going to talk about what is the CDK for Terraform, some different ways in which you can use it, and I'm going to tell the story about, HCL and moving to the CDK for Terraform and why that is. The why is important, which we will get to. Lastly, we'll talk about the CDK workflows and how those are a little bit different than using HCL. And then we're going to end with a demo. So please, I've prayed to the 5G gods and such and the other demo gods. So hopefully we'll be looking good on that front. We'll be walking through TypeScript and actually how we put all of these concepts together in a cohesive way and optimize workflows. So very, very exciting. We'll be doing that near real time. I think it's like maybe 10 millisecond delay. With that, I'd love to turn over to Kyle.
Excellent. All right, so I don't know how many of you kind of, follow Terraform. I'm kind of on the side of the eat, sleep, breathe, all things Terraform. So, if you go back over the last year, there's been some tremendous milestones that have been happening and development work that's been going on and all of these crazy things that have been, to provide amazing work. So we're going to cover a little bit about some of the things that have been released over the last year when it comes to Terraform. The first of which is going to be Terraform 0.14. Now, the main focus with 0.14 was basically on the user experience. How can we streamline some of those capabilities? How can we make the user experience better? And one of the ways that we did that was through the use of a feature called concise diffs. Now, for anybody in here that's run a Terraform plan that's against an environment that's already provisioned, you know that it gives you that plan, and no matter what happens, if things changed, if things didn't change, it output every single property and argument and attribute that went along with those resources. Well, that's not really user-friendly, and that can be a little bit above what we need to. So we went back through, and what we can see here with the little highlighted green area there, which in hindsight might not be as easy to read for the folks in the back, but basically we condensed the things and hid those if they're not changing. If they don't change, if they don't need updated, if they don't do anything along those lines, we just hid them because it's so much easier to read only the things that are changing. We also started playing around with the sensitivity part of the way the Terraform works with the individual values. So we started adding value masking. So, kind of hide what values you can see through the output of the console, as well as really focused in on the upgrade process. Those of you who have upgraded to at least 0.14 probably have noticed that there's really no upgrade tool anymore. That is kind of a thing of the past. Then we moved forward to 0.15. And really, in all reality, this was something that we couldn't talk about at the time, but this was all in preparation for 1.0 in that crazy milestone that we were trying to reach. And a lot of that work was focused on unifying the CLI experience. And what we mean by that is, making sure that no matter what terminal session, no matter what operating system you're using, you get the same exact experience. You see the exact same output. So there's no surprises, there's no changes, there's nothing that's, going along those lines. And then we did a lot of stabilization work. So these were bug fixes. These were, removing some of those deprecations that have been in the console, forever. So we fixed a lot of those things, removed those deprecation warnings. However, except for one thing, and this was around the undeclared variables. This was something that was deprecated. However, the community, you all in the room, gave us a ton of feedback that was basically like, please don't do that. And we greatly appreciate all that feedback. We took that into consideration, and we actually undeprecated it. Pretty crazy story there. Then we get into Terraform 1.0. And this was, I'm going to steal kind of a note from one of our engineers when we went through and started, kind of briefing everybody on what's happening there. Because everybody's like, okay, what are the features? What's new? What's going on here? And really, nothing. Like the entire goal behind Terraform 1.0 was around stability, was around being able to kind of, create a baseline so that you can continue to upgrade your Terraform versions over the next 18 months, which was something that we'd never said in the past. And you can feel confident that your workflows are not going to change. You're always going to have functioning code, and while we may add new features or functionality to it, we're not really going to be removing anything without at least fair notice. So diving into some of the things that went into the stability side, let's talk about state compatibility, because this was also a tremendous thing that, as people upgraded, there were things that changed, there were versions, formatting, all kinds of other things that were going on. And this was something that we stabilized on so that you can go not only forward, but you can always go backwards as well. Caveat there going back to 0.14. So you do have to make that leap at least once to get to that point. But at that point, you don't have to update versions. You don't have to do anything along those lines. You can continue in a pretty streamlined process as you update versions. And then for some of you who might be using older versions of Terraform, we also took that into consideration as well, specifically around isolating or pulling out values from those state files that are generated by older versions of Terraform. And this one's also pretty extreme because you can go all the way back to 0.12 to pull some of those values out so that you can still have the same functionality as you work through the upgrade process to get to 0.14, 0.15, or hopefully 1.0. And then I do want to touch on one point here real quick, and this is around that sensitivity area that we worked on. We added two new functions known as either the sensitive function or the non-sensitive function. And this is, it does exactly what it sounds like. You basically can take values that might be plain text and make them sensitive. Make sure that they aren't output to the console or they aren't output to the logging systems that might be following those processes. And then you can also do the same thing. You can take something that is sensitive and make it unsensitive or non-sensitive by using that same function. I will also throw out the caveat here because the next question that comes up with that is always, what about the state file? And I will throw out there, this does not modify the state file. It's still going to be there in the same way and fashion that it's always been. This is only for that output through logging systems and to the console itself to just kind of try and privatize what's being created and what's being distributed there. All right, one other area that I want to cover here really quickly because it's part of Taylor's demo as he works through that process is around Terraform Cloud. And this is a hosted service that is run by HashiCorp. It's an infrastructure as code cloud service. And basically what this does is we have multiple tiers that you can use all sorts of different features and functionality in. What we're going to be seeing today is everything that's on the free tier. So that means that we can store remote state in Terraform Cloud, so we can add role-based access control to kind of constrain who has access to what when it comes to the state file. Taylor's also going to be showing a remote execution, which means that we're actually running our Terraform job in Terraform Cloud as well. And then there are all kinds of other niceties and additional features in there, including like getting into policy as code and cost estimation. So with that, let me hand it over to Taylor.
Perfect. All right, who's ready for some story time? So to understand what the CDK for Terraform is, it's important to understand about how it came about. So with that, you may have heard this ever popular quote before, and it's why. I ask that all the time about a lot of things myself. It's a useful question, and it's one that you should be asking yourself when adopting a new technology or investigating a new workflow. So why we want to use the CDK for Terraform? Because. It's the best answer to the question why is because. And that's also my answer to anything I've made up my mind about. And of course, I'll elaborate a little bit more on that front. So we start here with HCL, HashiCorp's configuration language. And it is that. It's a configuration language. It allows us to do a lot of things. We have providers and resources and all of these very useful constructs with which to stand up infrastructure. Let's go back and talk about Terraform and its beginnings to help us understand that why a little bit more. So this was the only way to infrastructure as code with Terraform was HCL. And that worked really well. So as I said, it came with providers. So you can actually pick a provider, AWS and Kubernetes. And with each of those providers, that unlocks all of these different resources that you have available to you. It's really like adopting a new superpower, whether it be invisibility or stability in prod. And it opens up quite a lot of doors for you. You get this ability to craft within either or both of those infrastructures. Now, Terraform also enabled you to use functions to work with templates or file paths, base64 decoding something, for example. You could create templates. There's a lot of functions that are available to you. Which are incredibly helpful. We also had variables in HCL and inputs. So we could actually define, what do I want this project to be called? What do I want this Kubernetes cluster version to be? And kind of pass in those inputs and then reference them in all different places, minimizing the amount of places that you'd actually have to define that, because nobody likes manual work or typing, right? It's really stressful. With outputs, we also had this ability to, after these things get created, to then output what that actually looks like. So if you have a database connection string and you want to stand up your infrastructure and actually reference that after the fact, you have this ability with outputs to do that. I've also seen some people do some really interesting things with outputs as well. If you've ever stood up a Helm chart, for example, I've seen people actually put up a whole paragraph of how to work with the resource that they just stood up. So really creative use case and documentation as far as allowing people to actually work with outputs a little bit more. Another thing that I've really liked working with is locals, too, when it comes to variables. And those are enumerations of a sense. So you could actually use functions. Say I'm standing up a VPC, and I don't know what those subnet spaces or VPC IDs are going to be. I could actually put that into a local and then reference that within Terraform so I don't actually have to know what it is during the planning or the applying time. Lastly, we can create modules using all of these things and more, and then start to ship out that code to others and actually package up our solutions. So HCL allowed for teams to create those configurations that can reference variables, modules, and other values within the code. So even in this EKS snippet that I took here, you can see, I'm referencing variables for the first two items over here. I'm specifying a version and a source of where I'm actually pulling this. This is the Terraform public registry, where I'm able to pull that. That's also a really great tool I'll talk about in just a second, kind of talking about the ecosystem. But we can reference modules here. It's just a really great thing to be able to have all these pointers available to you to reference and then create these things, right? So this meant a huge reduction in all the places that you had to change within your infrastructure as code. Now, the next natural progression for that was creating the Terraform registry. So people were creating modules, and they were able to kind of package up the expertise in these blueprints for production, which is great. It's difficult to stand something up once, and being able to kind of automate that is fantastic. And being able to share that's even better. So we got that done, and we created the Terraform public registry. So you can actually take a look at different reference architecture and actually look at this code on GitHub and other places and actually see how this is done. So you don't even have to adopt it. You could fork it. You could take a look at it. And I swear I learned something new just about every time I go to take a look at a module or take a look at a provider. It's really, really a lot of fun. The registry allows for teams not only to share modules, but also their providers and version them, and share documentation as to how they're used. Great place to check to see if you have the latest version of it as well. Now, with all these inventions and shapings that took place in the community, we solved a lot of problems that existed before. Many teams were happy and were able to accomplish things that they'd only previously dreamed of. Though the teams that this helped were mostly operators and systems engineers, so that wasn't everybody. Say you're not even a person. Say you're a pug that's really good at TypeScript. We've left you out, and that's not cool to do, right? We want this to be something that's accessible. So as infrastructure as code took off, it left out those people that didn't have time to learn HCL, or just they're like, no, I'm good with Python, or it doesn't fit into our system. You have to talk about tooling and workflows, and some people were left out of that, and we saw that. So you could write a Terraform provider in Go. That was one option. Or you could create some custom tooling on top of Terraform to template things out or to run certain things. But infrastructure as code with Terraform is still only possible with HCL. Thus came the Cloud Development Kit for Terraform, or CDK-TF. Don't say that 5 times fast. I've tried it many times and just untied my tongue before this session. The CDK for Terraform allows you to use familiar programming languages to define and provision that infrastructure. So that gives you access to the entire Terraform ecosystem without having to learn HCL, and it lets you leverage the power of your existing toolchain for testing or dependency management, whatever it might be. So the other nice thing that comes about this is I get asked quite a bit about, OK, well, that's great, but when can I use the Kubernetes provider for the CDK for Terraform? I'm writing in TypeScript. When's this going to be ready? The answer is it's ready today. So all of this code gets generated as you need it, and it takes the existing providers and modules as they are today. So you don't have to wait around for something to become available. It's because it already is. I'll talk a little bit more about why, it's Terraform all the way down, and I'll talk to that in just a little bit as to how this actually works. So currently, we support these languages. We were really excited to add Go recently, so definitely check it out if you see your name on the list. Still working on COBOL, but we'll get back to that one. We use the JSII library, so as new languages get added to that, that's kind of the bottleneck for those things right now. So if you want a language that's not supported, please open up an issue. Let us know. I know a lot of people say don't at me, but at me. Let me know. Let's have a discussion. There are 2 big components when it comes to the CDK for Terraform as well. So today, I'm going to be using both. The first one is the CLI. So that's the thing that you're going to interface and act with a lot within your terminal. The next is the CDK-TF, which are all of the libraries and interfaces and constructs that you're going to be working with too. So with all of that, let's actually get into the workflow. What does this look like? This is the fun part. So these are some of my favorite and most used commands that I use for the CDK for Terraform. So the process is that you'll create a folder, which you've made a great choice, the CDK for Terraform. Yes. So now we're going to start things off, and we're actually going to initialize everything out. That's what the init command is for. That's going to pull down all of these dependencies for you, run npm install if you're using TypeScript or JavaScript, and just set the stage for everything that you're about to do. As you add dependencies and things like that, you will use CDK-TF get as well. That's going to pull everything in and actually create those, in real time, create those interfaces and generate the code to interact with modules, providers, et cetera. Next is synth. So what that's going to do is after you define all of this out in your code, you're going to run CDK-TF synth, which is going to create a JSON file, which was synthesized from all of your code. So that's JSON that Terraform actually takes and runs, whether it be a plan or an apply or all of these other options. So you could actually, after you've generated that JSON file, navigate to it within that folder and then run Terraform commands. So there's nothing up my sleeves. I don't have sleeves. And you can actually see all of these processes work, which is quite nice. So all of you who've ran Terraform might have run Terraform plan, hopefully. And CDK-TF diff is basically Terraform plan on that front. It's going to give you the diff of what your infrastructure looks like and what you expect to stand up. And lastly is deploy, which provisions that infrastructure. Now, with great power comes great responsibility. We hear that quote all the time, and it's annoying because it's true and it's overused. But it is very much the case here. So now that for those of you who've used Terraform with HCL, you'll note that there's extra complexity on top of that when you use the CDK for Terraform. And that's because you're closer to the metal, so to speak, when you're working with all of these things. There's additional constructs and contexts to make note of. So the foundational classes to build a CDK-TF application are app, which is going to encapsulate everything, then different stacks. You should have at least one, and then resources like we talked about before. Each CDK-TF project has one or more app instances that act as that container for the infrastructure configurations that you can create and deploy. An app can have one or more stacks that represent a collection of related infrastructure. So as you can see, that might represent development or testing or integration. Quite nice. So a stack represents a collection of infrastructure resources that the CDK for Terraform synthesizes as a separate configuration. It's equivalent to a Terraform working directory, which is nice to kind of help organize your code. I know it's been dry out here in Vegas, but you can keep your code even drier if you're using these constructs. Resource represents the definition for one or more infrastructure objects, which is exactly the same as you would have experienced with HCL2. If it's a load balancer, if it's an EKS cluster, or a VPC, that's what you're working with there. Definitely recommend checking the documentation for all of the things that you can do with those resources as well, because, again, reading the docs are always helpful. Like we talked about before, I want to take a moment of silence for this amazing way that which we solved this to generate those interfaces and everything like that with the CDK for Terraform. It automatically extracts the schemas from existing Terraform providers or modules and generates those necessary code bindings for your application. So this is, I'll actually dive into that code and show you what that looks like too. It's pretty neat. So here are a couple of code snippets just to kind of hit everything at a high level, and then I'll dive into the demo. This is an example of how we go about importing Terraform providers into our CDK project. So you can see we start with the construct from constructs, and that's kind of the baseline for everything that we're looking to stand up with the CDK for Terraform. Sets the stage for us, gets all the libraries ready. Next up are the CDK-TF libraries and different interfaces that we'd want to use there as well. So app, Terraform stack, I use a lot more in the demo code, and I'll walk through those too. And then the AWS provider, which is from this generated directory, and then we'll take a look at that. And it's as easy as standing up new AWS provider and then passing a region to that. I live in Los Angeles, and we're kind of close to Oregon here as well, so we've kept this as US West too. Next up are the stacks that we talked about, so those different environments or stacks that you want to stand up. This allows you to create multiple different environments too, like I talked about, and you can create multiple stacks, so keep note of that. Next up are functions, which are very important. So as you're working with your favorite programming language within the CDK for Terraform, you might go and reach for your favorite base64 decode method or something like that. Or you might already have something that you want to use that is provided by that native language. Definitely check the FN library, though, as this is going to help you a lot. Something that I bumped my head on a couple times while writing out this demo was the way in which the CDK for Terraform synthesizes things. It actually will synthesize a pointer or something like that, and that's not what you want to do. You want that to be lazy loaded into everything. You might not have all the variables that you need at the time in which you're synthesizing or doing a diff or actually applying the infrastructure. So there are constructs in which to use. In this case, definitely take a look at functions. That's definitely one warning I have for you on that front. Really, once I saw that working, it was wonderful. And then tokens. So kind of expanding upon what we had talked about with you might not know everything during that initial pass or when everything is synthesized. Tokens help with that. Tokens also help with casting the right variables too. So if you have subnets and Terraform generates a certain type of, has a specific data type, and that's not what your code is looking for, you can use tokens to cast that into the correct thing here. So that's what we see with the public subnet outputs here. It gives you a string. And so we want a list of strings, so we're able to use token and then cast that correctly. We're also able to use that, if you're using a data source or something. Again, if you don't have that, wrapping it in a token is the best way to go on that front. And with that, I'm going to jump into the demo here, but there are many more elements and contexts within the CDK for Terraform that I encourage you to take a look at in the Terraform IO website. Today, what we're going to be going through is standing up a VPC network in AWS, spinning up an EKS cluster, and we're going to have some worker nodes with that because we want to do some work, right? Or at least spin up some Nginx containers. Not only will we spin up infrastructure using this code, but we'll be declaring a Fargate profile to schedule our pods as well. And I'll also share some learnings with you there. So go ahead and switch into the demo here. All right, so home sweet home, VS Code. All right, here we go. So first off, I'm going to point to the CDK-TF JSON file. And this is where we're going to declare everything. Now, I already have some work cut out for me because we released the CDK for Terraform 0.8 today. This is coded with 0.7, so I just added some to-dos to my code to take a look at that later. One of the biggest things that changes are how dependencies are managed and some other nice housekeeping things. One of which that I had to change for this demo was the way that the application is run. Again, this is a TypeScript application, so apologize if it's not your favorite language, or COBOL. But we're gonna go through that and kind of happy to answer questions as it pertains to the other programming languages later if you want. So this was one thing I had to change, and this is something that is changed in 0.8, is it uses npx, tsnode, and then main ts to actually transpile and get everything ready and synthesize it. As we go about declaring providers, I like pinning as specific as possible, because as you do that, everybody's definition, it shouldn't, but the truth is everybody's definition of breaking changes differs. So if you specify all the way down to the bug fix version, you should be pretty safe. You at least have that repeatability and that knowledge that what I stood up is what other people are going to stand up. So that's why these specific tags here. But always recommend to tag as much as possible, and then to be very declarative about all of those updates as you make them. So here, just like Terraform providers, this is where I go and declare those. I'm pulling these in. I'm going to be using two modules from the Terraform public registry today, the VPC module and the EKS module. So they use all of these different providers, so that's why there's so many, despite just using two modules. Later on here, we can see the two Terraform modules that I'm using, like I said, VPC and EKS, and I've also pinned those as well. All right. So we'll walk through the code here, and then I'll kind of show you what we have. I'm not going to actually stand up an EKS cluster. It's going to be the proverbial, I've baked you a cake, and then pull it out from underneath the podium, just because it takes quite a few minutes, and wanted y'all to enjoy the session. So like we talked about before, we have these constructs, right? So we can see that we've pulled this in. We talked about the CDK-TF. You can see I've imported a few more namespaces here, namely function, remote backend, and token that I'll talk through here shortly. We're pulling in the AWS provider. I'm also pulling in the EKS namespace as well, because I want to authenticate to my Kubernetes cluster. It's very important. You can't do anything without your house key, so not too much fun. We're also pulling in the Kubernetes provider, and then the VPC and EKS namespaces from our modules as well. All right. So now we get into what does it take to define a stack and spin all of this stuff up. So I've named this my stack. It took me a long time of deliberation to come up with that. So it's like, whew, I'm glad we settled on something. One thing to note when you're working with the CDK for Terraform is if you know a value that you are going to use or declare, it's important to use the native language constructs to declare that. So here we're going to be using some constants, the project name, and the CIDR that I'm going to be using, because those aren't going to change. And if I do, they're in a place where I can easily see them, reference them and change them. Next up is the Terraform Cloud Remote backend. So I could run this locally. It makes for an easy demo, but I really like using Terraform Cloud because I have that auditability, and I can brag with team members about how many times it took to stand something up before I actually got to 200 OK. So really helpful here. Again, we'll talk about Terraform Cloud in a little bit as we're making some changes and spinning those things up. You give it a host name, an organization name. This is my online moniker here, so that's my organization name. And then this mirrors the GitHub repository in which I have all these things, optimizing AWS workflows. Next up is the AWS provider. Pretty straightforward here, just spinning up an AWS provider and providing it with that region as well. Now, I've declared some of these things statically, but you can set them up with Terraform variables and use locals. All of those constructs exist, but I just didn't use them here to help kind of convey some of these concepts. So know that is, if this absolutely can be dried up a little bit more and refactored. Next up, we're creating that VPC. We're also assigning that to a constant called VPC. And so with that, we're able to access all of those methods and properties and everything like that where it comes to the VPC. So again, we're using that project name at CIDR. We're opening this up to 3 availability zones, and then we're opening up public and private subnets as well. I work closely within the Kubernetes ecosystem. I'm in a couple different special interest groups on that front, release and docs. And one of the things that was a fun learning with an asterisk was we have to tag public and private subnets, depending on your Kubernetes version. So Kubernetes it knows a lot. It knows how to do a lot of things, but one of those is not interpret, is this a private network space or a public network space? All it cares about is that bits are flowing, right? Kind of like UDP, it doesn't matter if you get it or not. So we tag these with ELB and internal ELB so that the subnets and Kubernetes know where to route and how to place things. We also want to put the cluster name in as well, so it can actually associate that to the right EKS cluster. So if you have an ingress controller, or if you're working with load balancers and standing up those services, it actually knows the right place to put those and the relevant security groups. We're turning on DNS host names and NAT gateways because we like connectivity. Connectivity is fantastic. Awesome. Next up, our EKS cluster. So I've defined these values as well. And this is the first time in my code that you see the token construct. So here, I'm casting that to as list because, as we can see, if we go over here, it's expecting that array. And here, it's just outputting a string, which is not what we want. So we have to cast that appropriately. We're also using the VPC constant that we had here. And I'm able to use that because it's expecting a string. It is a string, so I don't have to do that token workaround here. I'm not writing out the Kubernetes configuration as well. I want to pull that in. I always want to get the latest on that front so I can actually authenticate. I'm going to be using the AWS CLI to pull that in. And then lastly, we're spinning up some worker groups, just spinning up 3 EC2 instances to then back my cluster. If you'll ignore the commented out code, that's going to be for a demo as we go and apply some changes. And then lastly, we need to authenticate to the Kubernetes cluster. And this is where a lot of those new CDK for Terraform constructs come into play. We want to reference that EKS cluster, which we also had a constant for. We get that endpoint there. And then this is what was really interesting to kind of discover as I was working through this code. I've got an HCL representation of a similar stack. And so taking that, transforming that for the CDK for Terraform and TypeScript, this was one of the hurdles that I faced was, what function do I use where and when? And so here, I'm base64 decoding. I'm using the data source for the EKS cluster. And I'm actually pulling in that certificate authority certificate and decoding it. And then I'm able to give it the project name and then pull that data that my stack expects. Lastly, like any good cluster, you've got a token to authenticate with. So I'm using token here, pulling in to cast that appropriately, and then pulling in that data source as well, and getting the token so I can actually authenticate. And then lastly, this is the glue code that puts all of that together. So we've been able to walk through everything and get everything set up. Again, there's one quick thing I do want to walk through is the generated code. So you can take a look here. This is get ignored here. You would never want to check this in. But you can see here that in the modules, you can see that all of this was generated as I went and got that, and before I actually ran my code, which is really nice. And really, really excited that I don't have to write all of this, as we see quite a few lines. So great, fantastic. All right, so with that, let's go ahead and shift on over to the command line. I'm going to get some things kicked off here. So I have already stood up this cluster. I'm going to go ahead and pull in my EKS, my Kubernetes configuration. I have aliased kube control, cuddle, CTL, to the letter K, because typing is hard sometimes. And I'm going to be using Kubernetes shorthand as well. So you can take node and shorten that to no. So let's go ahead and take a look. So right now, we're going to be looking at 3 instances. Awesome, cool. I didn't even have to pray to the demo guys. Whew, we're good. OK, so we can see that we have 3 EC2 instances in which all of these things are getting scheduled. All of our workloads are getting scheduled to. So we can also take a look at the pods. And I have one deployment called Beacon, which is just an Nginx container, and shows the host name and some other nice things for demos. We can see that we have 3 of those. So fantastic. Everything is running as it should. But say that we get a stakeholder and they want to mine some Bitcoin, and priorities have shifted at our company, so I have to go ahead and change things. These are under-provisioned machines, and it's wasting money. So and we could be mining Bitcoin or doing something else. So we have to change this. OK, fine. We'll go ahead and do that. So we can see we have everything set up the right way. Everything is running as expected. We'll go back and we'll actually take a look at the code. So we want to add these Fargate profiles, right? And it's really nice because it's going to stand up exactly the amount of compute and memory that you need within EKS. So the nice thing about EKS is you can have these tiered infrastructures and run things as you need them. If you need GPU, you can do it over here. If you want to run with Fargate, you can do it over there. And basically create this really complex or simple, complex, whatever kind of cluster that you need for your use cases. So with this, I'm going to spin up a Fargate profile. And you have to give it a name. You have to give it a network space to operate within as well. And then you have to add some selectors on that as well. So with this, I'm going to select kube system, because I want to run kube DNS within Fargate as well. And then I'm just operating within the default namespace within my Kubernetes cluster as well. And so I've added the worker type Fargate to my YAML. So I should be able to get this deployed and get this up and running. And then I'll kind of go through the rest of my demo here. So I'm actually going to kick this off. I'm going to turn over to Kyle to kind of talk through the Terraform Cloud and just some of the niceties in which that gives you as well, as it synthesizes, plans, and then applies everything as well. So I'll go ahead and do that. I'll shift this over, and you'll kind of see that running in the background there. Make sure this gets kicked off. Might take a second, too, with Wi-Fi, but I'll take a look here. Cool. Turn it over to you.
So you prayed to the wrong gods on this one. It's apparently to the internet gods.
The old and the new.
Yeah. All right, so what we're going to see here, since Taylor did set up the remote backend that connects back to Terraform Cloud, is we're going to see some jobs start kicking off, especially now that we entered into the planning phase. So this is our Terraform Cloud console. This is already in that specific optimizing AWS workflows workspace area. So if we click on our runs, we should hopefully see that the run that Taylor kicked off is already in the planning phase. So we can already see that that's running because it's doing remote execution, which means that it's running that job actually out in Terraform Cloud so that we don't actually have to worry about what's happening on our local system once the JSON file gets uploaded. So while that's running, let's take a look at some other things that are going on within this workspace overview page, which is fairly new to Terraform Cloud in and of itself. So up here towards the right-hand side, we can see some really good information about what's going on behind the scenes. So if you're not familiar with Taylor's code and what this workspace is doing, you know right off the bat that there are 61 different resources that are under management with this workspace. You can also see that we're using Terraform 1.0.11 and the last time that it was actually updated and run through that process. Then down here underneath the overview pane itself, we have our latest run. This is the job that's kicking off in the background right there behind it, we can see that we've hit the planned and finished stage, which means that it's starting to roll into the next apply phase of what's going on here. By scrolling down a little bit more, we can also see a little more insight into those 61 different resources that have been provisioned. As part of this, we can see information like the name that was created as part of Terraform. We can see which provider and which module it came from. We can see all kinds of different information. As well as if we had any outputs, we could also see that within this pane. Then, since that is still trying to kick off, moving to the next phase, we will, we have.
Oh, I think I know what I did. I forgot to save my file, which is always important to do. It's like, it's the little things, right? Okay.
As always.
All right, there we go. And again, so one thing I didn't mention is the -- auto approve. So we're experts, we're masters at deploying production workloads that may or may not work. So we call this a Terraform YOLO, where you add the -- auto approve and don't actually type yes to confirm that. So absolutely do recommend that you plan and confirm those changes before you go to production. But in this case, let's have a little bit of fun, right? It's almost Friday. Should be good. No deploys on Fridays.
Absolutely. We are trained professionals, at least during the business hours. So some of the other things as that continues to roll through, we can also get into the different tidbits about what's going on with the workspace's configuration itself. So like over here to the right-hand side, we can see that this is set up for remote execution. If this is backed by a Git-based repository or a version control system, we would also have a link to that. And we can see that we did the appropriate thing on Terraform Cloud side, in which we're not using auto apply. We're going to leave it to Taylor to do that immediately at the console instead. Then we also have some metrics that we can go through as well. So we kind of have an understanding of that, when we kick this off, it's going to be, roughly about 3 minutes to work through the entire apply duration. We can also start kind of naming and shaming Taylor for why he actually failed this 21 different times.
I thought you weren't going to bring that up. What the heck? Okay.
And that's what happens when you give me too much time to fill. It just happens. It's a thing. Then we move on to some additional things like metadata. You can apply some tags. This is really great for filtering and searching and trying to bring out and draw out specific views within Terraform Cloud and the individual workspaces itself. All right, looks like we're actually kicking off, running through the apply section now. So the last thing that I want to cover down here is our contributors. Now, contributors may mean something a little bit different on the open source side, but when it comes to the Terraform Cloud side, this really means contributors to the workspace. So think of these as your permissions or your role-based access control method. So in this case, we only have owners who have access to this, but if we had some folks who were maybe like read-only on the AWS side, we could add those as a specific team. So now if we click back into our runs, we should hopefully see, there we are in our applying phase. So there are a couple different nuances that are going on here in this output as well. So what we have here in our plan is what's known as structured run output. So because we're taking advantage of that JSON-based file that we've generated through the CDK for Terraform, we can also kind of generate a better visual representation of those resources that are being managed. So like here we can see that we're modifying or changing something that's within our EKS module. And then we can see that we're changing or adding a couple different things such as our Fargate profile and the policies that are associated with that. And then as part of this, we also have our cost estimation that if that's set up and configured, that's integrated into Terraform Cloud automatically. And then we can see kind of what's going on behind the scenes with our apply as that's continuing to kind of scroll through there within our terminal session. So it's probably going to be about another couple seconds before it gets to that point. But another kind of cool thing that we can point out here is that you can also include messaging as part of the either the approval process or as it goes through the workflow. You can add comments so that you kind of have an understanding of what's happening and why. And then we get into the state versions that are being created since we've reached the end of this particular portion of the demo. But another nice part for Terraform Cloud is that if we scroll up to our states tab, we can actually see all the different states over time so that we kind of have the ability to tell a story about all the things that have gone on with this particular workspace. So with that, since we've reached the end of our completed run here, let me hand it back to Taylor to continue forward.
Perfect. something that's always good is to apply yourself, and especially with Terraform. So we've done that. We've done that. We're in a good place. So let's take a look at what we've done. All right, let's go ahead and clear this out. And let's take a look at our nodes again. Awesome. Shoot, we only have 3. What the heck's going on? So what's going on with this is the way in which Fargate profiles work is that they only take effect the next time you actually deploy that, or the next time that a pod gets scheduled. So I'm going to do something that, again, you should never do in production, and that's we're going to go ahead and delete all of those pods. Yeah, don't let me near your clusters. Watch out. OK, so we're going to actually get these deleted. We're going to get that confirmation, and then the shell is going to return here. And then we're going to kick off one of my other favorite commands here, and that is watch. So we're going to go ahead and do that. And it's going to take about 60 seconds to run. So one of the things I've been bugging Kyle about forever is adding a cdk-tf song command so that we could actually get like the Jeopardy theme song maybe. Or I know there's a Spotify provider for Terraform, so a deploy playlist, something like that. But I keep getting rejected. I don't know who to talk to about that. But
Oh, if only.
yeah. But yeah, sad. But so you have to wait with me in silence as we wait for these pods to come back up. But really nice. Cold boots are difficult, but always a little bit better when you have some music to enjoy it with. So as we get to 60 seconds here, we'll see the containers creating, and then hopefully, OK, we're good. Well, we got running pods. So we're going to take a look at these shortly once this last one comes up. Go ahead and close out of this. And then we're going to go ahead and get those nodes again. And here, we're going to see 6 different nodes, and we're going to see Fargate IPs on each of these too. So as we delete these, or if we were to switch back or take off that label that specifies the worker group type and specifying Fargate as the value, these would go away. So really handy and helpful. There are some nuances too, which I'm not going to cover today, but there are some nuances too. Like you can go completely to Fargate profiles if you wanted to. Typically, you have to schedule kubedns, and so that's where you get into some issues. But it is possible. There are just a couple other considerations, just as another disclaimer out there. But always happy to talk with you about Kubernetes and AWS and Terraform. So with that, that concludes our demo today. We can go ahead and switch back to our other slides. And yeah, so again, people say don't add us, but I'm not going to speak for Kyle, but kind of am. Please feel free to add us on Twitter, to reach out to us, reach out via email. You can follow Kyle and maybe even his beard too, but you probably want to talk to Kyle. I don't know if his beard is going to get back and answer your questions. But with that, I think we've got some time left today, so happy to answer questions if you have any. Otherwise, feel free to find us on the front. Yeah. Yeah, absolutely. So the question is kind of like how to, if I'm hearing right, kind of how to iterate through with like for and count, and kind of like how do these concepts apply to the CDK for Terraform. So there are many different ways in which you can use that. You can use locals or dynamic or all of those different types of blocks too. Granted, you're right, the definition of those is a little bit different. I haven't worked with those just yet, but I can definitely look up something for you on that front and kind of show those constructs. But like you said, yeah, sometimes when you're even in HCL, those become very difficult. I think last time I had some fun with that was dealing with the certificates and getting those issued through AWS, and then dealing with that host name and the permutations of the FQDN and things like that. But yeah, we can talk after. Cool. So with that, there was, so the question is kind of like when you're using ACM, for example, how would you be able to, if you have a chicken and egg type problem, how do we go about delaying for that or waiting for the right time to actually spin those things up? So with that, I'd say probably the best thing for that really is going to be using the depends on construct. And so if you're able to do that, I know in some cases it does get very cyclical and you have to bounce around, but. There is one module I can point you towards for ACM creation. There's the organization that myself and another coworker have. It's called Operate Happy. That's our goal. And so that we actually do have a module for standing up those ACM certificates and then like CloudFront distributions as well, because we encountered that same problem. So I can actually show you some demo code on that front. Or you could take a look at Terraform, registry.terraform.io, Operate Happy. And then if you take a look at the ACM modules, those are good examples. And again, happy to jump on a Zoom call, reach out, talk, and engage a little bit more. Absolutely. Any other questions?
And
I think good question. So the question is kind of around when transforming from HCL to CDK, where there are like frustrations, just some kind of like contrasts between the two. Oh, gotcha. I think with that, it depends on what it is on that front, but it definitely could take a look at each of those nuances. But I think that in terms of getting things prioritized, obviously opening up an issue or anything like that, and then upvoting, that's something we look at very closely here at HashiCorp, and that helps us prioritize things out and kind of getting that feedback to like justify where to raise things a priority. I think with HCL and CDK for me, I think some of the biggest things have been just like how to deal with those different data types. So kind of like with this demo, working through, like I could do all this in HCL and it was very direct and straightforward for me. And so transitioning that thought process to having to then cast things that previously, like those types, everything worked really well before, and then having to kind of like step into that and adjust for whatever the language is. I think those were some big things for me. And then kind of dealing with those dependencies too. Those are always an issue, with whatever you're working with. A lot to consider on that front. So I'd say those are the biggest things for me. And then the functions was another big thing for me. Starting with like A, T, O, B to decode things, and nope, buffer from, nope, function, got it. Some things like that. So just kind of the nuances of the language itself and how to work with that was the biggest thing for me. Awesome. Any other questions? So with Terragrunt, so good question. Actually, I would say you're kind of popping the stack when it comes to something like that. So I think that, and I would say like when accounting for that, I'd say probably taking a look at app and stacks. It's supposed to emulate those different folder structures. So you might even be able to do that within the CDK for Terraform, whereas you weren't with Terraform before. Kind of giving that power back to you with the CDK to be able to do more things that you weren't able to do before. But yeah, good question. Yes. Yes, great question too. So that was, and forgot to touch on this, that's one thing that the recommendation right now is that, and I have feelings about, I'll tell you about after, but in terms of standing up everything in one Terraform apply, there are some pros to that, but there are also some cons to that. And currently, the Kubernetes provider right now, the way in which it works is that if you instantiate, you stand everything up, that is what's recommended, and then configuration after the fact, so that you're not doing it all in one fell swoop. Terraform is great for infrastructure initialization, but configuration management is definitely where the line is at, and it's very much a gray area and kind of like figuring out where that is. I've run into the same things too, and that's why in this code I did the data sources for Kubernetes, because you can do that or have your cluster upgrade, for example, whether it be EKS or a database or whatever. If something switches and flips and you don't have the right token or endpoint or something changed, you're locked out, that's not cool. So data sources do help with that. both in HCL and the CDK for Terraform, I've come to find, and then kind of breaking up and breaking apart those abstractions. So I'm standing up the cluster, and then installing Helm charts or applications, whatever it might be, within a separate Terraform file or CDK stack. Cool. Any other questions? Yes?
Yeah, we ended up having lots of like a wrapper around Terraform where we generated with like templates, like Go templates mainly. And would you say that like the CDK would be like a replacement for this, or it's just like just a wrapper over like HCL, basic HCL? Like how dynamic do you expect to get this, or that's my question. Like, so would you suggest us to just like drop all those templates and then just get to CDK?
Yeah, great question. So the question being kind of like if you're creating templates and ways in which to bring Terraform into your workflows, if you're adding some other templates or other kind of workflow concerns, how does CDK help adjust for that? Now I'd say I have seen a lot of people use makefiles and things like that to kind of like this is the way with going and applying things when it comes to their stacks. But I do think that the CDK, I'm interested to see. I've seen a couple teams and people start to do that as well, and kind of like get rid of wrapper code and then kind of write their own code to fit better into their workflow. It allows you a lot more room to do that. So I think in the long term we will see that. So cool. Yes. I'm so sorry. I was trouble hearing you. You said you were talking about HCL and. Yes, great question. So time and patience. No, there are some commands within the CDKTF. I think there's a convert, if I'm not mistaken. And so you are able to take that HCL code and see what that might look like within a couple different configurations and languages. You can, I didn't show it today, but you can spin up, like a deployment in Kubernetes and things like that. And that's where that convert command is going to also help out and kind of give you a better understanding of how to define that within your code. Yeah. So the question is, can you combine, HCL and CDK for Terraform? You can. I think that the best way to do that would be probably to create those different stacks or those workspaces and kind of like basically differing Terraform state and then referencing to one another. A lot of people I'll see, typically the Terraform journey is a main TF file with like 10,000 lines of all of your infrastructure. That's like starting to work with it and then breaking that out and kind of like taking more of a microservice approach with everything. And then I see teams then move later on to like, okay, we're going to stand up our network layer and then manage that with Terraform, whether it be HCL or the CDK. And then integrate like an application cluster, and then an app. And then so you have this like layered or just this graph of interconnected things and dependencies and kind of seeing teams work with things in that way. But, and always happy to chat more too to answer any other questions that you have on that front. But yeah, it's definitely a process, and sometimes it takes retooling or re-architecting. But cool. Any other questions? Yeah. So I apologize. I heard. Does that? Can we connect with like Vault and use things in that sense with? Okay. Yes. So we can use the Vault provider and kind of interact with it that way, and that is available too. You could synthesize that with the CDK for Terraform and then interact with that and configure that on that front. Awesome. I know we have just about a minute left, so we're going to jump off stage, but happy to answer any other questions that you have today. Again, feel free to reach out to us via email, Twitter, LinkedIn, all the above, and hope that you enjoyed the session. Thank you all so much for coming and sticking around. Have a good one.